Hello all. So till now, what we were doing is that we were understanding the basic concepts with what happens in one server. Okay. But now scale up little bit. Now we will try to understand like if there are more than one servers, what actually happens. Okay. Now we are actually landing to the main distributed system theories. Okay. So the first topic is replication. So in this video, we will learn this video is basically introduction to the replication. Okay, there will be many upcoming videos where we will understand more problem statements and their solutions. Here I will give some hints of the problem statements, but yeah, whatever. Okay, so what is replication? So this is our let's say we are running Facebook. Okay, these are the mobile devices which are accessing the Facebook. They go via load balancer, and from load balancer they go to the Facebook servers. Okay, so there are multiple Facebook servers, and the Facebook servers get the data from the DB. Okay, now what is the point of failure? So before understanding the point of failure, let's break like any one of the system. Like okay, so what if server one goes down? Cool, no problem. The traffic for this mobile device can be transferred to server 2. Obviously, this will make server 2 work more. The application may be slow for these two people, but at least they will be able to use the application, right? But what if the DB goes down? Well, none of the server can get the data, okay, due to which the whole Facebook will be crashed. So what can we do? We can make a copy of the data in another database. Okay, so this is database 1, this is DB1, this is DB2. So even if this DB1 goes down, all the traffic can come here. Okay, this is use case 1 of replication. Use case 2. Okay, so this is a database and there are multiple clients and all of them are like reading and writing from the same database. So this guy is also writing, this guy is also writing and reading, this guy is also writing and reading. What happens that this database get overwhelmed by so many requests? So what can we do? Well, we can do this thing that all the writes goes to the primary, okay, and reads goes to the secondary. This helps the primary to only take the writes and secondary only serves the reads, due to which the primary has to work less, and secondary also like the traffic is distributed, due to which secondaries also have to work less. Okay, so this is the use case number 2. Use case number 3. So let's say there is a database in US. Okay, let's say there is a Netflix database in US. Okay, and they are posting, so this is Netflix. Okay, they are posting videos in US database. Now this is a user, okay, who is watching the movie from US database. This guy also stays in US. Cool, he can watch the movie very easily. But let's say there is a person in India. If this guy goes and watches the movie from US database, the latency will be extremely high. Correct. So what it does, that this database replicates to a database to India, which is present in India. Also, this database replicates the database which is present in Europe. Now the Europe guy get his own database, Indian guy get his own database, US guy get his own database, and the traffic flow will be extremely fast because like it's in local area, right? So they can access the database very easily. So this is use case number 3. Now the second question is, what are the kind of replication that happens? So let us first understand asynchronous replication. Okay. So what happens in asynchronous replication is this guy writes to the primary database. Okay. Once the write is complete inside the primary database says, okay, it's done. Then in background, what it does in like it replicates or it copies the data to another secondary databases. Okay. Pros and cons. So the pro is like it is extremely fast. You just have to write in one database. Con is just after you have written the data and before replication, what if this primary goes down? Okay, what if the primary goes down? In that case, the replication doesn't happens to the secondary. Okay. Second problem is like, let's say you have written the data at time t1. Okay. And the replication happens at time t3. Okay. At time t2, some other person came and tries to read the data. So let's say previously the data was a equals to 50, and at time t1 you make a equals to 100. Okay. But at time t2, this guy reads the data. He founds that a equals to 100, a equals to 50, because it was previously written. After time t3, this db also makes it time t equals to 100, a equals to 100. So this guy basically got stale data. Okay, so these are two cons of asynchronous replication. uh, how to fix this? Next video. Okay. Okay, second option is synchronous replication. Okay, so what happens in synchronous replication? The user writes the data to the primary writes, makes a copy to the secondary. When secondary says yes, it is done, it sends the acknowledgement. Then it goes to like the third guy. It says yes, the changes are done, cool. Then it sends the acknowledgement, and then this guy goes to the user and says all everything is done. Okay. Pros and cons. Well, it is extremely slow. Like we can see, this whole flow will first go to the, like, let's say this is db2. This will first go to db1, then it will go to db2, then it will go to db3. Okay. Then it will acknowledge the user that this write has been done. So it is extremely slow. Second, what if this db goes down? Okay, this will never send the ACK, right? So like it will even slow down the whole system even more. And again, you can say like, what if the primary goes down? Yeah, then you are screwed basically. Okay, so still now what we are saying, that if the primary goes down, we are screwed. Okay, so can we do one thing, that what if there are more than one primaries? Okay, so if primary goes down, we are saying we are screwed. So this is basically single leader kind of replication. Okay, where there is only one primary and it is replicating to multiple secondaries or whatever. But can there be multiple primaries? Yes, there can be multiple primaries. So in this case, let's say in multiple primary, both primary can actually write the data, and then there can be multiple secondaries which can replicate from them. Okay, they can do sync or async, whatever they want. Okay, anyway, so problem statements. Let's say at the same time, this guy sends primary one. So this is one, this is two. Okay, this guy sends primary one, a equals to 100. At the same time, this guy also sends primary 2. This is that a equals to 50. Both have written primary like a equals to 100. This primary 1 has written, primary 2 has written a equals to 50. When they sync, they say that what is the actual value of a? Is it 100 or is it 50? Well, this is one of the problem. There can be conflicts. Second problem is, what if like due to some case the DBs are running properly, but the router between them is not working properly. So this guy thinks that I'm the primary, this guy thinks that I'm the primary, and they just write. And after, like, let's say 1 hour, the router got fixed, and now they are like they really don't know like who is having the actual data. There are a lot of conflicts. So how can we solve them? Like, there is only one way, that let's not make more than one primary. Okay, and once the primary is down, make someone else primary who is having the like latest data. Okay, but still in that case, what may happen that let's say the router goes down. Okay, now they can't decide like who is primary, but in this kind of cases always what happens that when there are multiple primaries, okay, the number of primaries should always be 2n plus 1. Why? Because it is very unlikely to happen that all the routers goes down at the same time. Okay, so let's say somehow this guy got disconnected. Okay, even if they are like primaries, not secondary, sorry, primary. Okay, this guy got disconnected, or like let's say this router goes down, they can still communicate, right? This guy will say that, hey, I got the connection, so still this guy is primary, there can be some problem with the router, just wait for syncing up. Okay, or even if like this guy completely goes down, who can be the leader? So these two can do leader election. Okay, so the problem which I was saying, like if they are two clusters and the router goes down and they can't decide who is the actual primary, who has the actual latest data. So let's say a equals to 100 over here, which happens at time t1, and a equals to 50 over here, okay, which happens at time t2. Now they can't decide like who is the real primary because the router went down but databases were up. The problem statement is basically called split brain, okay, where your brains are basically split. Anyway, so this was the solution. Cool. Now the question is like, how can we replicate? So there are multiple ways how you can replicate. So one is like directly copying. So there are pros and cons to everything, but okay, whatever. So SQL, let's say you are doing and you are trying to like write like insert a equals to 100 at time dot now. Okay, at time dot now. Now the problem is like time dot now can be different for one server present at US, and time dot now can be different in another database which is present in India, right? So yeah, this is not very good solution. Second is write ahead log, which we have read previously. Write ahead log. This is very good, but this can be a problem when you are replicating to two database using two different softwares. Okay, so for example, in MySQL, okay, MySQL, Akash equals to 100 is stored. Okay, and the information is, let's say, stored at 00AFF. Okay, but when you replicate it to Postgres, okay, uh, so what happened that this kind of memory address is not used in PostgreSQL. Okay, so PostgreSQL won't understand like what we have to do. So in write ahead log, you told that write a equals to 100 at memory 0x0AFF, but Postgres doesn't understand this kind of pointer and it's screwed. It can't do that. Third option is using replication log. Okay, replication log. So what happens there? That you provide an ID. Okay, so let's say you provide ID 1 where Akash equals to 100. In ID 2, you provide uh, Ashish equals to 200. Okay. Now, ID is just an integer or like uh, whatever data format, let's say integer. Okay. So this is same in either Postgres or MySQL. So this kind of replication won't be very difficult. Okay, so these are like three kind of replications, three ways how you can replicate. Cool. So ultimately, like concluding this video, what all we understand, like why do we need replication? Okay, what are the use cases of replication? Then we read about synchronous replication and asynchronous replication. Okay, one thing I forgot to tell, that in synchronous replication, the data is strongly consistent, whereas in asynchronous replication, the data is eventual consistent. Uh, so I gave the example in which, like, at time t2, the user is reading at asynchronous replication and he finds out the stale data, right? So that's why we say it is eventually consistent. Okay. Also, we understood little bit of about like master master and master slave kind of architecture. In master master architecture, we have seen the pros and cons. Also in master slave architecture, we have seen the pros and cons. How to fix them, we will understand in upcoming videos. We have understood little bit about the split brain, although we will see about like we will learn more about that in the upcoming videos. And like how replication happens. So there are three ways. One is like, first is like sending all the data to another database, okay, like to another database server. But obviously the problem will be like if time.now or this kind of things are used, the timing can be different into database. Second was write ahead log, the pros and cons we have seen. And third is replication log. Okay, so this is the intro. Thank you.